Hey everyone, welcome back. Today we are diving into a massive tech frontier that sounds straight out of sci-fi, but it is happening right now. Brain-computer interfaces, or BCI. When most people hear BCI, they immediately think of Elon Musk's Neuralink and brain surgery. But there is a whole other side to this, right? The non-invasive kind.
Exactly, and it is huge. In fact, non-invasive BCI, where you don't need any surgery at all, makes up almost 86% of the entire market right now. The commercial potential is massive, with the global BCI market expected to hit nearly $11 billion by 2033. And what is really exciting is that in this specific clinical research area, China is running completely neck and neck with the absolute top international levels.
That is impressive. But wait, if we are just putting sensors on the scalp without opening the skull, getting a clear signal must be incredibly difficult. I mean, the human skull is literally designed to protect the brain.
You hit the nail on the head. The skull is basically made of collagen and porous structures that do not conduct electricity well at all. Professor Xu Minpeng from Tianjin University has a brilliant analogy for this. He says invasive BCI is like watching a game from the VIP front row, while non-invasive BCI is like standing completely outside the stadium trying to guess what is happening just by listening to the muffled crowd noise. The signals are incredibly weak and heavily distorted.
So how have researchers traditionally dealt with listening from outside the stadium?
Historically, it has been pretty rough. A typical setup means washing the user's hair, spending 20 minutes applying messy medical conductive gel, and then having them stare intently at a screen with characters flashing at specific frequencies. This triggers a measurable brainwave response. But staring at flashing lights causes massive visual fatigue, the user's focus eventually drops, and the gel dries out. The whole experiment just falls apart after a while. Plus, if a paralyzed patient has eye movement issues, they cannot even use it.
Okay, so that clearly needs an upgrade. How is the Chinese research team tackling this bottleneck? Did they find a way to hear the whisper through the stadium walls?
They did, and it is a major breakthrough. Professor Xu realized that for 50 years, the industry was stuck on those old, fatiguing methods just because the signals were bigger and easier to read. He totally changed the paradigm. Instead of making users stare directly at flashing targets, his team moved the stimuli to the peripheral vision. They also pushed the flashing frequency above 30 Hz, so the human eye barely even notices it. No more staring, no more intense eye fatigue.
That sounds way more user-friendly. But if the flash is barely noticeable, wouldn't the brain signal be even weaker and harder to detect?
That was the genius part. Xu hypothesized that since the brain is structurally symmetrical, the background brain noise should also be symmetrical. By comparing the left and right hemispheres, they could mathematically cancel out the background noise and isolate the true signal. Thanks to this, they became the first in the world to accurately identify brain signals as incredibly faint as 0.5 microvolts.
Wow, 0.5 microvolts. That is a game changer. What kind of real-world control does a signal that precise actually give you?
It completely unlocks complex controls. In 2020, they used it to fly a drone, controlling its movement in multiple directions and rotations using just brain waves. Then they shattered a world record by creating a system with over 100 command sets, which they later upgraded to an astonishing 216 distinct commands. This means a user can handle complex multitasking, like navigating virtual environments or operating advanced robots, incredibly fast.
That is mind-blowing. But let's be real for a second. Even with 216 commands, nobody wants to spend 20 minutes rubbing conductive gel into their hair every time they want to turn on the TV or fly a drone. Are we going to see hardware that feels like consumer tech anytime soon?
That is exactly what they are working on right now. The goal is to shrink the bulky EEG caps down to the size of a small hair clip, completely dry, with no gel required. And on the software side, they just released an open source platform called Meta BCI this year. It provides standardized APIs for the whole industry. Think of it like the HTTP protocol for the internet. It ensures that different devices and algorithms from different labs can seamlessly communicate and build on each other.
So they are not just building the tech, they are building the entire infrastructure for other developers to jump in. That is how an industry actually scales.
Precisely, and they are already integrating generative AI into these platforms too. But as Professor Ming Dong, the dean of the institute, pointed out, this field requires deep, long-term commitment. China needs to avoid low-level, repetitive copycat research and boldly push into the uncharted territories of original science to truly lead this new frontier.
Focus on the hard stuff, not just the quick wins. Got it. No surgery, reading 0.5 microvolt whispers from the brain, and building the internet protocol for human thought. The future of BCI is moving incredibly fast. Thanks for breaking this down for us today, and thank you all for listening. We will catch you next time.